Okay, now we have the remaining part of our discussion of structuring a module. Previously, we looked at this original prog2.py module, which had a function definition followed by two print statements. And we saw that the downside of this design is that if another program like prog3 imports prog2, not only will prog3 then have access to execute this f2c function, but also through the mere act of importing prog2, these two print functions are automatically going to be executed. To prevent that automatic execution of those two print statements, what we did was to modify prog2. We called it prog2a. And above the two print statements, we added this if test. If dunder name is equal to dunder main, then execute the two print statements, otherwise not. Now, dunder name will only be equal to dunder main if prog2a is the main module. That is, if prog2a is the program that we're directly executing. But if prog2a is imported by some other module, then that other module is the dunder main, and this imported module its dunder name will be prog2a. And so these two print statements will not occur. Now we have one more improvement to make. Sometimes we do want to execute the code contained within the if part of the module. That is, rather than preventing these print statements from being called, sometimes we do want to execute these print statements or the equivalent thing. And so what we can do is another trick of defining a function called main. It can be called banana or howdy doody. You can call it anything you want, but the convention is to call the function main. And then, optionally, a program that imports this module can decide whether to call this module's main function or not. So here is prog2b, which implements this idea. So in prog2b, we're defining a function called f2c. That's the primary thing that we want to make available to other modules that import this module. But rather than having these two print statements down underneath the if test, we instead are defining a main function, and below the if test, we are calling that main function. Now, another program that imports this module prog2b, can decide whether or not it wishes to invoke the main function out of this prog2b module. All right, so let me show you the program. All right, so here's our prog2b module, and here is a program that is importing prog2b and using its facilities. Okay, so here's prog2b on slide 3, and here is the revised program, prog3b, importing prog2b. Okay, so prog2b is this file, prog2b.py. When in prog3b, which is my program that I'm executing, I import prog2b as p2. In prog2b, the function f2c will be defined and available, and the function main will be defined and available from prog2b. So now I can execute p2 f2c P2 F to C, P2 F to C. If I wish, and to illustrate that it works, I am going to wish. If I wish, I can also execute the main function contained within this prog2b module. All right, so let's run this guy now. Prog3b. We're going to say run module. There we are. So let me scoot my output over here. So in prog3b, we import prog2b as P2. So prog2b within the prog3b program is going to be referred to with the abbreviation P2. The F to C function is defined within prog2b. Also, the main function is defined within prog2b. All right, so we print that 32 in Fahrenheit is 0 Celsius. 212 Fahrenheit is 100 Celsius. And 76 Fahrenheit is 24.444, etc. Celsius. We then get to this print statement. And because prog3 is the current main module, the value of dunder name is dunder main. Now we print a message saying, okay, we're going to run prog2b's main code, and we now invoke p2.main, and that in turn, all right, come back here. Where are you? I guess I've got it hiding behind here. Here we go. And that invokes prog2b's main function, which prints out that 80 degrees Fahrenheit is 26.666 centigrade Celsius, and this module's name is prog2b. Okay. So let me illustrate with some other commonly used modules. I am in my shell, and the shell always believes, when you're interacting with it, that it is the main module. So if I say underscore underscore name underscore underscore, I get underscore underscore main. That is, if I say dunder name, I get dunder main. If I import math as m, now I can say things like m dot exp of 0, that had better be a 1, or m dot square root of 2, 1.414, etc. And I can ask m, what is dunder name within m? And that's going to be math. Okay, it's the name of the module. Now, another module that we're going to talk about soon is Numpy, which provides n-dimensional arrays and a lot of statistics facilities and linear algebra facilities. The conventional abbreviation people use for Numpy is NP. So with NP, I can say things like np.random. There's a random number submodule within the NumPy module, and I can ask for rand_n. What this does, rand_n, is to generate 5 random draws from a standard normal probability distribution. That is, I'm going to get back 5 values taken from a normal distribution with mean 0 and standard deviation of 1. And there we are. So this is a random sample from a standard normal distribution. And each time I run this, I will get back a different sample. Now, within the NP module that I've imported, dunder name is Numpy. And finally, Pandas, just as another example, this is a module that we won't have time to talk about in this class, but it has spreadsheet-like capabilities within it, and the ability to do convenient cleaning and manipulating of row and column kinds of data, and perform statistics and things like that. And it's a little large, so it's taking a few seconds to load, but eventually, when the thing decides to load, I can find out what its name is. Okay. I think I'm gonna, there we go. All right. Under name is Pandas. Okay. Now notice how long that took. Pandas.py is it's a pretty big file, or perhaps even collection of files, probably collection of files, and they all have to get loaded in and interpreted so that any function definitions that they contain, any class definitions that they contain, any objects that they contain, so that all of those things are pulled in and made available to me in my shell. And it takes some time to do that. The reason that Numpy was so quick, actually, I will tell you a secret now. The reason that Numpy imported so quickly is that I had previously imported Numpy into this shell while I was not recording anything. And once you have imported a module and you import that same module again, nothing really happens. So if I say import pandas as PD, it's legal to say that, but I've already imported it, so nothing really happens. Alrighty, so that gets us to the conclusion of defining and using modules and what this dunder name and dunder main thing are about. And we have a lab here that will help you get a little practice with modules.